High in 3 separate alpine cirques, a small aquatic insect is logged every summer in shallow mountain tarns, pools that, by midwinter, are frozen solid to the bottom, with no unfrozen layer beneath the ice. This past winter, a research team drilled an ice core straight through one tarn at its coldest point and pulled up a section with several nymphs of the species frozen inside it, motionless, encased. Back in a lab under warm water, some of them began to move again. Nobody set out to study this insect. The 3 tarns are monitored by 3 different projects: a glacial retreat survey, a water chemistry study, and a routine biodiversity transect, each visiting high cirques for reasons that had nothing to do with insects. The species turned up in all 3, incidentally, in field notes never meant to be compared. It was years before anyone noticed the same insect appearing in write-ups from 3 unrelated teams, on 3 mountains with no ridge low enough for it to fly between. It is a small, pale, cold-adapted insect in its nymph stage, living entirely underwater in these tarns until a brief, short-lived adult stage each summer. Its close relatives are known from fast-moving alpine streams, where cold water keeps flowing even through winter. This species is unusual only in where it has chosen to live, not in flowing water, but in small standing pools that lose all liquid water for months at a time. Aquatic insects that survive cold winters almost always avoid freezing rather than endure it. Eggs are laid to wait out the cold in a dormant state. Larvae retreat to deeper, spring-fed water that never quite freezes through. In the handful of documented cases where an insect does freeze and survive, it is almost always a larva on land, buried in soil, not something living in open water that turns entirely to ice. Bathymetric surveys of all 3 tarns rule out a hidden refuge. Each is shallow enough and cold enough for long enough to freeze completely to the substrate every winter, a fact confirmed the hard way by ice cores drilled straight through from surface to bottom at 3 different points in each tarn in 3 different years. There is no unfrozen layer for anything to wait out the cold in. Whatever is surviving here is surviving inside the ice itself. The comfortable answer is that nothing survives the winter in the tarns at all, and each spring's population arrives fresh, adults flying in from some unmonitored source population, low enough over a ridge, or carried further than expected on a strong wind, to found a new generation each year in water nobody sees them arrive at. Under this reading, the frozen nymphs in the ice core would simply be an unlucky late cohort that never got the chance to reach adulthood, not evidence that the population itself survives the winter. Multi-year dispersal surveys have not helped this explanation. Marked cohorts of adults, released and tracked in aggregate rather than as individuals, show a flight range far short of the distance between any 2 of the 3 tarns. Ridge-by-ridge transects across every plausible corridor between the sites, run across 6 summers, have never once recorded the species anywhere outside the 3 tarns themselves. No stragglers, no scouts, no source population waiting to be found. The stranger alternative is that the ice core caught the population doing, in the open, what the record already hinted at from a distance, surviving the winter frozen in place inside the tarn itself. A handful of insect species elsewhere are known to tolerate freezing by flooding their tissues with natural antifreeze compounds, but always on land, buried and insulated. Nothing in this genus has ever been documented doing it submerged, in open water, with no soil and no insulation between the animal and solid ice. If the population is surviving in place, its tissue should show it. Nymphs recovered from ice cores at each of the 3 tarns were tested for the same class of protective compounds found in known freeze-tolerant species. All 3 populations tested positive, at concentrations higher than any previously recorded freeze-tolerant insect, land-dwelling or otherwise. Not every frozen nymph revives. Across repeated ice core sampling, the proportion that resumes movement after thawing varies noticeably between the three tarns, in a way ice thickness and core depth alone don't explain. One tarn's population revives at a consistently higher rate than the other two, year after year, despite broadly similar winter conditions across all three sites. Whatever determines survival, it is not simply how deep or how cold the ice gets. The network's researchers split on what the variation means. The first holds that it is simply local microhabitat noise, slight differences in sediment, insulation, or ice clarity between tarns that a larger sample would smooth out. The second holds that a consistent, repeatable difference in survival between three otherwise similar populations points to something inherited and site-specific, as if each tarn's population carries its own, separately tuned version of the same underlying tolerance. If the second camp is right, it raises a distribution question as pointed as the biochemistry. Three populations, on three mountains no adult has ever been shown able to cross, each holding its own slightly different version of an ability found nowhere else in the genus. That would mean each tarn's tolerance was not inherited from a shared source recently enough to still match. It would mean each population has been quietly refining the same trick alone, for longer than anyone monitoring these tarns has been alive. Nobody in the network argues the insect itself looks unusual. Seen in a net in midsummer, it is an ordinary, easily overlooked aquatic nymph, the kind of thing a survey logs without a second glance. What resists a comfortable filing is what the ice keeps returning. Nymphs that should not survive being frozen solid, reviving at rates that differ by tarn for no reason yet found, in populations that cannot plausibly be exchanging anything with each other at all. This season, for the first time, each tarn has a temperature logger frozen directly into the ice itself, recording continuously from first freeze to spring thaw, rather than relying on cores taken at a single moment. Whether the readings show three populations riding out one uniform winter, or three quietly different ones, won't be known until the ice comes up in spring. The forest keeps its own records. If this pulled you in, subscribe. New mysteries drop regularly across every series in the archive project. The next episode's waiting.